A payout annuity is kind of the opposite of a savings annuity. Instead of you putting money in constantly, you are taking money out. Okay, so the annuity is paying out um, to a beneficiary, essentially. So you start with money in the account and you pull money out of the account on a regular basis. So you're making regular withdrawals. And whatever is left in the account after your withdrawal, you're going to earn interest during that next compounding period. And after a certain amount of time, the account will empty. So this is the formula that we use for a payout annuity. And it looks very similar to the savings annuity. Really, the only difference is we've flipped these two positions and then put a negative in that exponent. And the meaning of all of these variables is pretty much the same. We do have this difference that on the left side of the equation we have P sub 0, P naught. And P naught is the initial balance of the account. So, suppose you save up and you end up with $500,000 in an account, and then you're going to start withdrawing. Then this P naught would be 500,000. D is the amount of the regular withdrawal. R is the annual interest rate. N is the number of times compounded per year, which should also be the same number of the regular withdrawals. And then the T is the number of years that we will actually be taking withdrawals. So this is the formula, and we might solve for the deposits, we might solve for this initial amount. Okay, we could solve for lots of different things here. Let's just go ahead and do an example. After retiring, you want to be able to take $1,000 every month for a total of 20 years from your retirement account. The account earns 6% interest. How much will you need in your account when you retire? So our payout annuity formula, okay, P naught equals D times 1 minus 1 plus R over N to the negative NT over R over N. Let's go ahead and identify some things that we have. First of all, this $1,000. That's our regular withdrawal. We want to take that out every month. So that's going to be D. Okay, so we have D equals 1,000. We want to do this for a total of 20 years. Okay, so that is T, the amount of time that we want to take our withdrawals. So T equals 20. The account earns 6% interest. So that is going to be, of course, our interest rate, R. So R equals, and we have to write that as a decimal, 0.06. And, of course, N is going to be determined by how often we do our withdrawals. And we're doing that every month, okay? And so that means that N is going to be 12 because there are 12 months in the year. So now we're ready to plug everything into our formula. We have P naught. This is the amount we want to start with, and that's what we're looking for. That equals D, which is 1,000 times 1 minus 1 plus R over N to the negative N times T all over R over N. So now we can go ahead and type this into our calculator. We have 1,000 times 1 minus 1 plus 0.06 over 12 raised to the negative 12 times 20. And then we divide this by 0.06 over 12. All right, and we have 139,580, and rounding to the nearest cent, 77 cents. And that's the amount that we are starting with in our account.